Hello guys, welcome back to my channel. So in the last video we have discussed about some equations of motion, but in this video we are going to do some problems using the equations of motion. Okay, so let's start. So the first problem that we get is a bicycle increases its velocity from 10 km per hour to 15 km per hour in 6 seconds. Calculate its acceleration. Okay, so we have to calculate the acceleration here. So what are we going to do is that we know that it increases its velocity from 10 km per hour to 15 km per hour in 6 seconds. This means that it was moving with a velocity of 10 km per hour. It increased its velocity to 15 km hour in time t 6 seconds. Okay, so let's write u, which is initial velocity, is equal to 10 km per hour, and v is the final velocity, that is 15 km per hour. Okay, and time is given as 6 seconds, but we have to convert the unit, that is seconds, into hour. We have to always remember that unit must be same. So 6 seconds can be converted into unit hour by 6 by 60 into 60 hours. As we know that 1 minute is equal to 60 seconds, then 1 hour is equal to 60 into 60 seconds. So to convert from seconds to hour, we have to do 1 by 60 into 60. So here, as it is given 6 seconds, we have to do 6 by 60 into 60. Okay, so now let us calculate the acceleration. As we know that a is equal to v minus u by t, so we can write it as 15 minus 10 by 6 by 60 into 60. Okay, so after that we can see at 5 by 6 by 60 into 60. Okay, so we will now just do simple calculations. 5 into 60 into 60 divided by 6, and now it's easy. 50 into 60, that is 3000 kilometer per hour square. So this is the acceleration, 3000 kilometer per hour square. So the next problem is a bullet hits a wall with a velocity of 20 meter per second and penetrates it up to a distance of 5 centimeter. Find the deceleration of the bullet. We can write u is equal to 20 meter per second, and the distance is given as 5 centimeter, and we have to convert it into meter. So it will be 5 by 100, or we can write 1 by 20 meter. And as the bullet hits the wall with a velocity of 20 meter per second and penetrates it up to a distance of 5 centimeters. So after moving 5 centimeters, it has stopped. So we can write that v, which is the final velocity, is equal to 0 meter per second. Okay, and find the deceleration of the bullet. So we have to use the third equation of motion here. V square is equal to u square plus 2as. Okay, so we have been given the v, u, and s. So we have to find the a. So to find the a, we can do a is equal to v square minus u square by 2s. So 0 square minus 20 square by 2 into 1 by 20. Okay, so now we have to just do the simple calculations here. So will be so the value of the acceleration will come in minus, because the acceleration is in the opposite direction of the velocity. As we have discussed earlier, that acceleration is a vector quantity, so it has direction. Okay, so we have to always keep that in mind, and it will be 1 by 10 minus 400 by 1 by 10, that is minus 4000 meter per second square. So this is the answer of our second problem. Okay, so the third problem is a ship moving with a constant acceleration of 36 km per hour square in a fixed direction speeds up from 12 km per hour to 18 km per hour. Find the distance traversed by the ship in this period. Okay, so we have been given the initial velocity, final velocity, and acceleration. Okay, so now let's find the distance. U is equal to 12 km per hour. V is equal to 18 km per hour. And the acceleration is equal to 36 km per hour square. 36 km per hour square. Okay, so now we have to find the distance. So we can use the same equation that we have used in the previous problem, that is v square is equal to u square plus 2as. So we have to find the distance here, so we can write s is equal to v square minus u square by 2a. Okay, so v square minus u square, so v square is equal to 324 and u square is equal to 144. So and 2a will be 72. So we can write it like this. So 324 minus 144. 324 minus 144 is equal to 180 by 72. So 180 by 72 is equal to 2.5 kilometers. Okay, so this will be the answer. Okay, so our next problem is a body starts from rest and moves along a straight line path with a uniform acceleration. The ratio of the velocities at t is equal to 1 second and t is equal to 2 seconds. t1 is equal to 1 second and let t2 is equal to 2 seconds. Okay, so the velocities, let the velocity of t1 will be, so as it is said that a body starts from rest, so the initial velocity will be 0 for both the cases of v1 and v2. So we can write v1 is equal to u plus a t1 and v2 will be u plus a t2. Okay, so now as u is equal to 0, v1 is equal to a and t1 is equal to 1, so a into 1 will be a and v2 will be 2a as t2 is equal to 2 and u is equal to 0. So v1 by v2 will be a by 2a, that is 1 by 2 is equal to 1 is to 2. So this will be the answer. Okay, so the next problem is the bus travels 1/3 of a distance with a speed of 12 km per hour and the remaining distance with a speed of 20 km per hour. The average speed of the bus is nearly dash kilometer per hour. So we can represent the distance here with a line and we can tell that let the total distance is equal to x and this is 1/3 x, and this is the remaining 2/3 x. Okay, so let's say d1 is equal to, so this is d1 and this one is d2. Okay, so d1 is equal to 1/3 x and d2 is equal to 2/3 x. So the speed for the first the 1/3 x is equal to, let's say, s1, which is 12 kilometer per hour, and s2, which is 20 kilometer per hour. Okay, so now t1, as we know that distance is equal to time into velocity of speed, distance is equal to time into speed, so time will be distance by speed. So let's say t1 is equal to d1 by s1. So here d1 is taken as x by 3 divided by s1, which is 12. We can write it as x by 36 hours, and t2 is equal to d2 by s2, which is x by 2x by 3 divided by 20, which is x by 30 hours. So total average speed, let's say SAVG, average speed will be total distance by total time. So total distance is equal to x by 36, x by 30. So total distance by total time. So we have to do just normal calculations here. Let's say plus 5x by 180, and this will be x into 180 divided by 11x. So the answer will be 180 by 11, which is approximately 16.4 kilometer per hour. So this will be the answer, 16.4 kilometer per hour. Okay, so what this problem says, a car starting from rest is capable of acquiring 40 meter per second in 20 seconds. The displacement is in 10 seconds. So we have to find the displacement in 10 seconds. So the u is given as 0 meter per second. So we have to write u is equal to 0 meter per second. T will be 20 seconds. So we can find the a here, as we know that v is equal to u plus at. So a will be v minus u by t. So v here is 40 and u is 0. So we have to write that v is equal to 40 meter per second. So we can now easily derive it. This will be 2 meter per square, and the displacement in 10 seconds will be, so f is equal to ut plus half at square. So u is 0, so it will be half at square, and from this we can easily derive the equation, that is half into 2 into t square, which is 100. So the answer will be 100 meters.
After this, if you like this video, please like, share and comment on this video, and please subscribe my channel and click on the bell icon to get notified when I upload a new video, and you can follow me on Instagram. Thank you.